are required when you talk about practical applications. So suppose I have certain maps are there, soil maps. So why should I worry about different classes? I should only worry about which type of soil is suitable for which type of agriculture, agroforestry, or etc. So then I should combine those soil maps together. Then you generate a map saying that these are the suitable areas. So that means you can, each class is again reclassified and generate an output. In this case, there is a city map. You see this. If I put this map and this map for decision maker, which map they prefer? So they probably prefer this map because it is giving him what are the commercial areas, industrial areas. Here it doesn't give, but if it is, you have to see every time to the connected table. So that means a huge task. Maybe here I have 15 values. Suppose there are 1000 values, and then it is a very difficult task to see this and compare with the table and then find out the suitability map, etc. So than this. So that's why this reclassification is useful for the certain type of applications. Another thing is there are maps are there, there are tables are there. Once you have a map, so that map can be converted into another map, taking that tabular information. Suppose if you see this, type is alphisol in this case, in case of 1. So here I converted into infiltration, what will be there in that. So similarly for this, number 2 is mollisol, and then you replace with the values. So then your value output is produced here. So similarly other applications here, you have a 3 type of these things, and then you can also, I also if then condition is set there, like if soil is equal to red Gina, then you convert it into 3 or otherwise. So this all reclassification is very useful. Then convert into zones if you have a DEM. So that is all possible here. In case of this is not much we don't use in GS, but you can also use, suppose I have an original map, I can classify that map into equal interval zones. So then I can say that I take 3 classes equally, and then assign the values for all those classes. So then another thing is equal frequency. So that means in each class, so then the frequency should be the same. Here the equal interval is, suppose I have 1 to 6 values, I take 1 to 2 is 1 value, 3, 4 is like that. So here what is the interval is uniform here. Here interval is not uniform. That number of cells in each zone, it becomes a this one equal. Another simple example is if I have a land use map here, and then this is I have a slope map. I wanted to generate a land use map which is having a steep slopes. So this red color is steep slopes. So that means it will show the forested areas where the steep slopes are there. For flood type of analysis, if there is a failure at a certain place, and then what will be the area inundated because of that? Suppose if there is a dam is there, it is broken. So then water will flow into this, and then you can calculate what will be the water spread. Yesterday also Professor Crack, he was mentioning how that Netherlands is getting flooded if there is a rise in water level. So they have a minus less than a 0 value of MSL. So first those things will be flooded like that. So here also you say specify this, my height is this. So then you can calculate how much area it is going to inundate. This is a dike failure, and then given a certain at MSL height, and then what will be the MSL height for this. So then you can get a different spread areas.